In this video presentation, we are going to discuss a one-way ANOVA using a medical application. It reads, medical researchers want to know if four different medications lead to different mean blood pressure reductions in patients. They randomly assign 20 patients to use each medication for 1 month. Then measure the blood pressure both before and after the patient started using the medication to find the mean blood pressure reduction for each medication. To understand whether there is a statistically significant difference in the mean blood pressure reduction that results from these medications, researchers can conduct a one-way ANOVA using type of medication as the factor and blood pressure reduction as the response. If the overall p-value of the ANOVA is lower than our significance level, then we can conclude that there is a statistically significant difference in mean blood pressure reduction between the four medications. So overall, there are four different types of medications, and you've got four different groups of people. So medications are the blood pressure reduction. The blood pressure is measured before the application of the medication and after the medication was applied. So therefore, the blood pressure reductions were calculated, and there's going to be a comparison to see whether or not there's a difference between that mean blood pressure reduction between amongst the medications. Now, it says here, if the overall p-value of the ANOVA is lower than our significance level, then we can conclude there's a statistically significant difference in mean blood pressure reduction between the patients, between the medications. So this is in fact comes from a p-value approach whereby the decision criteria is such that if the p-value is less than the significance level, then you have to reject the null hypothesis. And the null hypothesis for such a test is always saying the mean amongst the different factors are equal. That's what the null is bound to say. And the alternative is bound to say that there is a difference. At least one of them is different. So if the p-value is less than significance level, we have to reject the null hypothesis and conclude that there is a difference. So that is why this statement is saying if the p-value is lower than the significance level, then we can conclude statistically significant difference, meaning rejection of the null, and concluding the alternative. So let's look at the setup as a research with a topic. The topic is blood pressure, for example, and the research question is, do the four medications lead to different mean blood pressure reductions in patients? And that's talking about the population. And the hypothesis, which again is talking about the population, is responding that the four different medications lead to different mean blood pressure reductions in patients. That's a null hypothesis right there, because the alternative, that's the alternative hypothesis right there, because the null is saying that the means are equal. There's no difference. So the objective now is to determine whether or not the four different medications lead to different mean blood pressure reductions in patients of the population. So data has to be collected and a sample has to be taken. So using sample data to infer about the population or to test a claim which was directed towards the population. So here's the data. Here's the blood pressure reductions for each medication. Medication A, medication B, medication C, and medication D. So we need a calculator, an online calculator to use to input the data to conduct the test. And here we have an ANOVA, a Way ANOVA calculator, Statistics Kingdom, free online, and it is asking for to state the significance level. Outliers, we can include the outliers, and the effect size 0.25, medium effect round to 4. And we want to enter the raw data directly. So the groups are medication, and there are 4 different groups: medication A, medication B, medication C, medication E. So we need to add another column. So insert another column. We can click on this here, and that will be for medication D. 4 groups. And we can copy and paste the data. Highlight the data for medication A, Control C, and Control D. I'll do that. Repeat this for B, C, and D. So now we have our data inputted into the software. We can just click on calculate. And here we have the classic ANOVA output. You have the degrees of freedom, 2 of them, numerator and denominator. And we got the p-value and we got the F statistic. So we can copy this. It's our snipping tool to copy this and to paste it in our work. So step 1 now is to state the pair of hypotheses for p-value approach. The null will always say that the means are equal. There's no difference between the means of the blood pressure reduction due to medication. The alternative will say, well, not all the means of the blood pressure reduction due to type medication are equal. So the alternative is saying that there is a significant difference between the mean, whereas the null is saying there is no difference between the mean. Step number 2 is to input the data into the appropriate calculator. We have done that. And we have identified our p-value, which is 0.8453, because we are doing a p-value approach, and the p-value now will play the role as a judge. In the classical approach, the statistic here is an F statistic that would have done that. But now we are using the p-value. So therefore now we need the p-value criteria, which is if the p-value is less than the significance level of 0.05, we have to reject the null. But if the p-value is not less than the significance level of 0.05, we do not reject the null. Now our p-value is 0.8453, which is greater than the significance level of 0.05. So therefore now the decision now is not to reject the null. So if the null is not rejected, then we have to conclude that based on the data, all the means of the blood pressure reduction due to medication are equal. The difference, if there is any, is not significant. That's what we are concluding. And to do this in APA style, APA format, a Way ANOVA revealed an insignificant difference between the mean blood pressure reduction between the four medications. The F is degrees of freedom 3, and 76 is 0.2721, and the p-value is greater than 0.05. So that is why we are not rejecting the null, to conclude that there is an insignificant difference between the mean. And effect size, eta squared, was 0.25, indicating a medium effect. That's for further analysis. But the main point is that we got a p-value of 0.8453, which is greater than 0.05. So the null was not rejected. And the null is saying that there is no difference. If there is any, it is insignificant. And that will form our conclusion for that. Yes. So here's an ANOVA using an online software from this website called Statistics Kingdom, ANOVA calculator.